All right, in this video, we are going to solve these exponential and log equations. Let's take a look at the first example over here. When I first take a look at this example, I notice there are two terms multiplying on this side, and also the bases are not the same, so I can't combine them. We have a different base over there as well. So the first thing I want to do in this question is I want to split these terms up, and the only way to do that is to log both sides. Now I can use my rules of logs to split these into two different equations. So log 7x are not two different equations, but two different expressions. Log 2x squared minus 3. This one stays the same. Now that I've split these up, I can bring all my bases or my exponents down using my rules of logs. So x log 7 plus x squared minus 3 log 2 equals x log 7 over 4. Now in this next step here, I notice that x log 7 and x log 7 over 4 are very similar. So I'm going to move this to the same side as this because that's going to be really easy to manipulate around and simplify. Now I can just common factor out an x on this side here. Left with log 7 over 4 minus log 7. I can just combine these two over here. Using my rules of logs, I know one log minus another is just division. So I have 7 over 4 divided by 7. I can simplify that fraction now. And it's just going to be log of 1 over 4. Now I can just divide both sides by either log. I'm going to divide by log 2 because I know if I divide by log 2, I'll get a whole number, whereas if I divide by log 1 over 4, I'll get a fraction. I prefer to have whole numbers over fractions. Now, you can easily do this calculation without a calculator. I'm not going to explain those steps in this video because those are basic log steps, knowing how to divide two logs. Just have to make the bases the same, basically. Doing the calculator, I'll just get this whole calculation to be negative 2. Just get rid of my brackets now. So x squared minus 3 equals to negative 2x. Then x squared plus 2x minus 3 equals to 0. This is a simple quadratic equation. What multiplies to negative 3 adds to 2. It's just positive 3 and negative 1. Then I just get my solutions to be negative 3 and positive 1. So those are my two solutions for this exponential equation in the first question. Let's go to the second question next of this video, which is this log equation over here. Now, if I compare the two sides, the bases are not really the same, so I can't really combine these two terms. No point moving it. 1 is very easy to get rid of in log equations. I know I can just change 1 as log 2 because log 2 is the exact same as 1. I want to make these two bases the same. That's my first step in this question over here. Oh, and you know what? I'll also get rid of the square root and I'll turn this into an exponent of 1 over 2. Makes my life a bit easier. Next, I'll combine these two here. When adding two logs of the same base, we're multiplying whatever's inside the logs. So if I multiply 2 by 9x squared plus 1, I'll just get 18x squared plus 2. And on this side over here, I'll just bring my 1 over 2 exponent down. So I have 1 over 2 log root 2. And then same thing inside the bracket. The next thing I want to do is I want to make the two bases on the same side the same. So I'll do my change of base rule over here. So this, I'm going to simplify. Change of base rule is just like log AB equals to log CB over log CA, where you're basically getting rid of a base or changing a base to a different side. So I'm going to apply that rule over here. I'm going to change this base to a 2. Bracket stays exactly the same. I'm going to divide this all by log, and then this has to be the same base as this log always. And then your old base is the regular term over here. That's just basically this equation here, which is a change of base rule. Now log 2 is very simple to do. You can do it with or without a calculator. Basically, this exponent becomes half, and then you can cancel this. So this denominator here is just going to be 1 over 2. And then 1 over 2 and 1 over 2 just cancel. And then log 2, we have the same log on each side, which also just cancels. You're just left with 18x squared plus 2 equals to 2x 4 plus 42, which is just a quartic equation. And then I'm going to move all the terms to the right side and make it equal to 0. 2x4 minus 18x squared plus 40. Oops, why did I 420? Then I want to common factor this. I can common factor out of 2. So I'll just divide everything by 2. x4 minus 9x squared plus 20. This is again a simple trinomial. This is in the form of a simple trinomial. It's just a quartic equation. So what multiplies to 20 and adds to negative 9? It's just negative 4 and negative 5. And you can just solve these two equations separately, either difference of squares them or just solve them. Here x squared equals to 4, here x squared equals to 5, which means x equals plus or minus of root 2, or x equals to plus or minus of root 5. By the way, that's a root 4. I don't know why I wrote a root 2. And then the square root of 4 is just plus or minus 2. You can't square root 5. It's just a whole number. So if you need exact solutions, these would be your exact solutions right there. 4 solutions in this question. In total, if you were allowed decimal answers, you would just square root 5 in your calculator. And if I do that, I'll get approximately 2.24 if I round to do 2 decimal places. These are non-exact solutions. Again, just 4 solutions to this question. And when we have so many solutions, especially negative solutions, we should come back to the question and check whether they are all valid. But in this question, my x is squared, which means everything is going to be positive here. So that whole bracket is positive, which is good for logs. And this is to the power of 4, which means everything here will also be positive, which means we're good for the square root and for the log. So all these 4 solutions are valid. and they are good for this question. If you made it to the end of this video and you found this content helpful, please hit the like and subscribe button and help me get to 1,000 subscribers so that I can finally get my YouTube channel monetized. This is video number 526 without making a single dollar, so I'd really, really appreciate if you did that for me. Thank you for watching.